Today I am going to present you the prototype of enhanced AES encryption algorithm. So in here, I will first of all I will show you the prototype and give a little bit of introduction regarding my product. So this is the prototype which I have used Arduino technology and Arduino applications and sensors. So basically this is Arduino Mega board which is used to process the encryption algorithms and it itself, and this is the time locate real-time getting sensor, and the other one, this smaller one, is the GPS sensor which used to get the exact location, and this is the antenna of that GPS location the sensor. So now I will deassemble them each and every one, and I will show it to you how it is and how it is work. So the first of all I will get you the Arduino Mega board by disconnecting the cables of the sensors. So this is the Arduino Mega board. The Mega board taken as a processing part for this prototype implementation. So through this port I am importing the data, and within itself there is small processor and the RAMs. So using those things, encryption and decryptions are done. And the next part of the part is the small sensor, which is called as a real-time module sensor. So this is called as tiny RTC I2C module. So it's mentioned in here. So there are pin settings which need to be correctly identified in order to get the real-time basis. So this is a small battery which contains this will help to contain the date and time location and calculate each second accurately. And the next part of the device is the GPS module, which is called the Neo 7N module, which is latest module, and there are two parts. It is located. The first one is the antenna. Two antennas can be integrated to this particular sensor. So the one antenna can be connected in here and the other one in here. So I have both antennas to make sure that all the things are available for the project. So this is the one of the antenna which we can connect to here. It is to here. So like this, it's okay. It's fixed now. It's fixed. So this is the antenna which we'll use to get the exact location, and the other antenna for this one is this one. So antenna GPS antenna, sorry, this way around. Its GPS antenna and frequency is 1575.42 megahertz, and 3 to 5 volts are the voltages that this antenna works on. So I can get this antenna, this part, and connect it into here. So we can put this on a specific location without any interruption. So this is the whole module. So the two antennas were integrated in order to get the accurate information. So these are the two antennas which are connected to the Arduino GPS mini module. So this is the module, and these are the connectors which used to connect to the Arduino Mega board. So this is the project hardware that I have used to implement the Puzzle 2.0 solution. So let's move on to the implementation part, or the code, how it's working the Puzzle 2.0. So let's move on to that part. Now I am about to show you the prototype of AES enhanced encryption algorithm. In this particular algorithm, the special thing is there are 3 parameters included within the new enhanced algorithm. So the first parameter that included is the location, and the second part, the second parameter is the time, and the third parameter is the password. So in this enhanced encryption algorithm, the 3 parameters work together to generate the encrypted text or encrypted data. So what happened is, in the prototype, I have integrated separate GPS module and separate real-time module, and we can get a specific password from the user. So what happened is, when you enter specific destination location and specific time duration and predefined password, so all 3 of parameters going to work together to generate the encryption algorithm. So basically you will need to pass the password only to the receiver. So after the receiving the message, they need to get into the specific location with that specific time, and they need to input the password. The thing is, if the time duration is expired, they cannot decrypt the algorithm or decrypt the text, or even if the location is incorrect, they would not be able to decrypt the text as well. So the specific location and the specific duration and as well as the specific password should be there. All 3 things should be accurate in order to and decrypt the text value. So I will show you the first the scenario. So in here, my current location is located here. It's home Agama. This is the location which took from the Google Maps, and the parameters mentioned here. It is something like this. At the we need to enter into the board, and these are the parameters. So the target location or the destined place to decrypt this particular encrypted data is this location. So this is on Homagam Mahindraj Bakshi School. It is the target location. This is the latitudes and longitudes of the place, and these are the filtered. Those data are filtered. So time, it can be decrypted within 6 p.m. and password is for that is this one, and encrypted text is this. So this is the this is the parameters which used to encrypt. So when we are entering the data or the data into the as the parameters into the algorithm, this is the format which we need to follow. The first 2 things or the first 4 things are latitudes, and the second part is longitudes. For second part, second 4 numbers are the 4 digits are latitude, longitudes, and the other 4 are the time location. So the basically 18.00 means the 1 hour duration. It is for 1 hour durations available. They can decrypt the message, and this is the password up to here. So they need to have this particular password in order to decrypt. And this is the plain text which we going to encrypt. So I will copy this part, and I will move to my solution part. So this is the solution part. So this is the algorithm that I have developed by using the Arduino platform. So I will get into the inputs of the algorithm. So this is the viewpoint. So we have 4 options. The first one is the encryption destination, and destination should be something like that. This is the format as I mentioned before, and a decryption option, and the current location and time is available. So for the moment now I need the encryption part, so I will select the option 1 and input the parameter. So we need to wait a minute. Okay, so this is the encrypted text. This is the to be encrypted text, and this is the encrypted text that we have looking for. So I will copy this part and I will go back to the other end of the destination location, and I will show you how to decrypt it. Okay, I have reached to my destination or the targeted location. So I gave the 1 hour time of period to decrypt the encrypted text. So now I will share the screen of the location of mine. So this is my current location. So this is the latitudes and longitudes that I have to. And now I will show you my system's location and time. So when it's come to the so my current location is 3 means same, and for the time I have the fourth option. It's 6:29. So now what I am going to do is I am about to decrypt the data. So in order to decrypt, we need the password and the encrypted data. So encrypted data is something like this. So as we saw last time, this is the encrypted data, and here's the password. In here it's comma, it's used to separate the data. So I will copy this one and I will move to the move to here, and I will select option 2 and input the data and just wait few seconds to whether get it decrypted or not. So okay, so it's took some times, but it worked, so it's successful. So this is the text that we have submitted, and 2182 microseconds were taken to decrypt the encrypted one, right? So this was successful. Now what I am going to do is I am going to encrypt again from this location to my boarding place again around 7 o'clock. So the second part is here. So encrypted from this location, which is my current working place, and the destination of my boarding place around Homagama. So this is the parameters in there, and latitudes and longitudes, and it's selected. It's 5 o'clock. I will change it to 7 o'clock, and in here the parameters were selected first for latitudes, and the second for the longitude, and second part for the time duration. So 17, and I will move to the 19, and the password from here to the for the mark. So the rest of the part is plain text, which is the message. So I will copy this part from here and move to the console part of the Arduino. So Arduino console part is the first one. So as you can see, the format is written in here. So the location, time, or the 24-hour format, and the password with the 9-character password. So and the text. So I will select the first option, and I'll put the data to it. So here what we have got, this is the result, so encrypted part. So what I'm going to do is I will copy it and I will take it to my boarding place, and I will try to decrypt around 7 o'clock. So we will. Okay, I got back from the workplace to my current location, which is my boarding place. So let's see how to decrypt the data, whether it's going to work or not. So first I will share with the data that we have collected from the encryption. So this is the data that we have gathered from the encryption part. So this is the encryption text and this is the password. So in order to make the decryption work, we need both of the part to decrypt. So first I will copy all those things and I will move on to the input part. And before we move into that, let's see whether the locations are correct. And now we will check about the time. And time is also correct. Now we have the time to decrypt so the parameters, location are correct, and the time. So within the 7 p.m. around 1 hour time, we can decrypt this particular data. So it's 7:32. So let's use the decryption option there, option 2, and we'll insert the data. And we will just wait a couple of seconds whether it's going to work, check whether it's going to work or not. So in theory and the practicality, it should work. And output should be there, but let's see what will happen. So it's successfully decrypted. So you can see the time and the decryption details. So it's successfully decrypted. So the output was right. So this is the IIT at 1 is the results, and that is the one that we have encrypted. So now we can check, or we can try out another option with this going to work or not with the previous encrypted data. As example, we encrypted a few things, means one data previously from my boarding place to working location. Now the both parameters are expired on that particular encryption text. So the latitudes are expired and the time is set to the 6 o'clock. It's also expired. Now it is past 7 p.m. and the password is the only one that's correct here there. And if it is worked perfectly, the output text should be this. So let's see, this is the parameter that we took from the encryption algorithm, and this is the password parameter. So just copy it, and we will move on to the inputs of the ones, and in here that you can see. Okay. So the second option, I will again show the location and the time. Time is also changed. So only the password is valid there. So let's use second option. So this is the data. Let's see whether it's going to work or not. In theory and the practicality, it should not work because the location and the time has expired. Both have expired and only the password is correct. Now it should fail in the process, but let's see what will happen. It will take few seconds. Okay, it's failed. Decryption failed. The decryption result was unable to identify because due to the failures. So So this is, it took much time and it was failed. So this is it. So the time and the location are both are expired. So that is why it got denied, right? Or get failed on the process of decryption. So let's see whether the locations that I have traveled in order to make this work. So the path is, so this is the path that I have traveled from the Homagama town to the here. So these are the 4 locations, around 5 kilometers were there in order to make this work. So this is the implementation that I have done by using AES encryption algorithm, and also we can implement to other encryption algorithms as well. But for now, as the prototype, I have implemented in Arduino platform by using this basic the AES encryption. And thank you very much for your valuable time and staying with me and listening to my project prototype and projects. Thank you very much for your valuable time, and have a nice evening. Have a nice day. Thank you.